Hi, I'm Amanda West, and today I'll be talking about finding the determinant of a matrix by using row reduction. So we're going to start off with our matrix, which is going to be 2, -2, 4, -1, 1, 0, 0, 3, 1. And I'm going to find the determinant of this matrix by using row reduction. Okay, so first thing that I think about doing would be to get the first term to be a 1. And to do that, I can just factor out a 2 from this whole row. So what I'll do is this 2R1. And then what that's saying is that basically if you can take this whole row and divide each term by 2, then you're going to get here that's 1, this is -1, and this is 2. So we're going to put that back into our matrix. So now it's going to be 1, -1, 2, and then you just write down the other parts of your matrix just as normal, because the only thing that you changed was that you factored out a 2 from row 1. So now we write the rest, -1, 1, 0, 0, 3, 1. Okay, so that was our first operation. The next thing that you want to do is make sure that you want your leading terms to be these diagonals, and you want to make sure that whatever is below the leading term is a 0, because that's echelon form. So what I want to do now is to make sure that this turns it to a 0. And to do that, I just can add this row to this row. And what that's doing, what I'll write down over here is that I'm doing R1 plus R2. And what that's doing is this, 1, -1, 2, -1, 1, 0. I'm just putting this part down here. Basically, you can add this. And so 1 plus -1 is 0. -1 plus 1 is 0. And 2 plus 0 is 2. So now this is going to be R2, because I just added R1 plus R2, and that gives you this. So now we rewrite our matrix. So first row, 1, -1, 2. Second row, 0, 0, 2. And then since there was a 0 already here, you don't have to do anything with this last row, because all we were trying to do was make sure that anything below this, but below this first term, was a 0. So now we just write 0, 3, 1. Now, you want to make sure that there is a term in each of these, sections. You want your diagonal to have a term in each part. So what I'm going to do now is switch the third row and the second row so that I can have a term right there. So what I'm going to write to the side is switch. And then I'll just swap these. So I'm going to get this, 1, -1, 2. Swapping switch R3 for 2 for R2. So I'm going to move R3 up there, so 0, 3, 1, and then 0, 0, 2. And now we are in echelon form. And this is the form that you want when you want to get your determinant. So the general thing that you're going to do is that when you're taking the determinant, let's call this matrix A. So determinant of A will equal the sum of the terms in your the product of the terms in your diagonal, I'm sorry. So we're going to do, these are the terms in the diagonal. So it's 1, 3, and 2. But when you've done some changes to the matrix, like factoring out or row swaps, you also have to account for those. So I factored out a 2 early on, so I have to multiply this whole thing by 2. And I also swapped a row, and a row swap is equal to -1. So then you just have to multiply that as well. And so when you put all this together, this is 4, and this is -3. So -3 times 4 is -12. So your end result is that the determinant of A equals -12. And what this tells you is that since your determinant does not equal 0, the matrix is invertible, and this allows you to do a whole bunch of other things within linear algebra, and this is like the first step most times that you want to take before you do other things, and making sure that it's invertible and that the determinant isn't 0 can allow you to do a lot of stuff. Also, when you're solving with row reduction, this is also a way that you can find eigenvalues. So you just plug, when you are solving for the determinant of a minus lambda I to solve for eigenvalues, you could use row reduction for that. Also, if your matrix isn't a 2 by 2, or if it's a 3 by 3 that has kind of weird numbers and you don't want to use cofactors, then row reduction is the way to go. And definitely, when your matrix is a 4 by 4 or greater, row reduction is definitely the easier method to do, because you don't want to solve with a whole bunch of cofactors. It's a huge mess and it's too much work when row reduction is so much easier. So that is solving for the determinant. Pretty simple. So just go through these and you'll make your way to solving the determinant. And if you have problems with row swaps or switches, just do a whole bunch of row reduction on matrices and you'll get the hang of it. Thank you.